Bio-geochemist Charley Driscoll and forest ecologist Lindsey Rustad are taking a little hike through the woods, surveying their handiwork, you might say.
This quadrant over here, this is a big litter decomposition.
With support from the National Science Foundation, they're part of a team of researchers here at the Hubbard Brook Experimental Forest in New Hampshire that wants to know more about the impact of ice storms on forests like this. Easier said than done, since such storms are so hard to predict.
We'll be back there. Lindsay, look at that.
So they set out to make one.
And I don't think it's ever been done before. How do we quantify the level of icing? Really, the accumulation of ice is really critical in terms of the overall damage. We wanted to be able to be very quantitative.
We had pumps down in the Hubbard Brook that pumped water from the brook through a series of hoses. We had 2 of these vehicles going along either side of our experimental plots, spraying water 100 feet into the air. Came down as a fine mist. It was freezing conditions and it froze on contact.
So these ornaments are up there and they're getting ice as well as the branches?
They set up 10 plots, each about the size of a basketball court. Some got no ice, some got 1/4 of an inch, which is pretty light. Some 1/2 inch, the equivalent of a major storm. And some got 3/4 of an inch, considered extreme. Now they're into a multi-year effort to monitor how the forest is responding.
So what happens when we have an ice storm? It's a catastrophic event. It opens up the canopy. There are some trees that are able to recover from this. There are some trees that are not able to recover from this. This is an opportunity for the forest to rebuild itself.
On this day, they were measuring nutrient levels in the water from the soil.
When you damage the canopy, those trees are not taking up as much nitrogen and carbon and calcium. And if they're not taking it up out of the soil, that means it's in the soil and it can be leached into our streams and our lakes.
They also gather up dead twigs and branches that fall from the treetops, carefully weighing how much detritus is coming down from the damaged canopy. And they measure the amount of carbon dioxide and other greenhouse gases generated by soil microbes and plants' root systems released from the forest floor.
So if you have a catastrophic disturbance like an ice storm and you change the carbon cycling, and if you tweak that soil respiration even just a little bit, because it's such a big number, it can have a significant impact.
The goal is to quantify every bit of science data they possibly can about how this ecosystem is changing in the aftermath of the experiment. The trees, the soil, the water, even behavior of birds and insects.
So we're doing things like measuring the temperature of the air, the temperature of the soil, the moisture of the soil, so a cascade of physical impacts.
Driscoll says as our climate changes, we can expect more catastrophic weather events. Not just ice storms, but hurricanes, floods, and drought, too.
And as a society, we're going to have to deal with them at all levels and all types. And so I think the more we know about them, we are better prepared to understand their effects, to respond to them. It's going to be in our best interest in the future.
Simulating an ice storm to be better prepared when the real thing strikes. That's way cool. For Science Nation, I'm Miles O'Brien.